specifically about what? A chemical system. Is my voice clear?
Yes.
Okay, so whenever you are talking about heat exchange between a chemical system and its surrounding, then you will call this branch of chemistry thermochemistry, right?
Yes.
Okay, so a thermochemical equation is what? Let us talk about it. It is a balanced equation that includes the enthalpy change of the reaction. What is enthalpy change? Basically a heat change but at constant pressure. You have to keep in mind that this delta H refers only to the amount of a substance and their states of matter in that equation. What I'm trying to say here is whenever you are calculating the delta H, you have to calculate in terms of moles. Let me tell you like how we're going to talk about this. Suppose this is a chemical reaction, you are converting H2O into H2 and O2, right? And the first step for any chemical reaction is to balance it. This chemical reaction is balanced, and the delta H value that you are observing here is 572 kilojoule. And this is having a positive sign. So whether you are going to call it an endothermic reaction or an exothermic reaction.
Positive sign.
Yeah.
Um, endothermic.
Yeah, great. So the later one, what you are observing, the same value but with opposite sign, because now the thing which was in the product side, now you are taking it as reactant and converting your gases back into your water, right? So this reaction is exothermic. So what is important here is that thermochemical equation should always be in mole. Whenever you are talking about thermochemical equation, you should always consider them in moles, not gram. You don't have to talk in terms of gram, only moles. Is it clear?
Yeah.
Here in this reaction, what we can say? 2 moles of H2O are converting into 2 moles of dihydrogen plus 1 mole of dioxygen.
Okay.
Okay. Now, enthalpy, we have studied this in the thermodynamics chapter. Let us give a brief overview of. Okay. So, what is enthalpy? Heat changes constant pressure. This formula we have converted it from the first law of thermodynamics, right? What it says your delta H is nothing but your delta U plus P delta V. P delta V is your mechanical work, right? This is the relationship between your enthalpy and internal energy as well. Right? This formula is important. We have already derived it in the previous chapter. What is uh, what is internal energy? Again, heat change, but it is now at constant volume.
Yeah.
Now, exothermic and endothermic reactions. Exothermic reactions are those reactions where the heat is transferred to the surroundings. Okay, and endothermic is the reaction where heat is absorbed to the system, or you can say transferred to the system from surrounding. Is it clear? Endothermic and exothermic, I hope.
Yeah.
Now, a very important topic from this chapter is Hess law. Hess law basically helps you to find the change in enthalpy for any reaction. How you're going to do it? You have to basically create some sort of relationship between two reactions with the help of which you have to identify the third one. I will tell you how you're going to proceed. So let us talk about the definition first. The heat absorbed or evolved in a given chemical reaction is sum whether the process occurs in one step or several steps. Is same whether the process occurs in one step or several steps. What can we understand with this statement? Whether your heat is absorbing or evolving, right? Whether it is going to take 3 steps or 4 steps, right? Or you can directly see from initial to final state, both will have same value. What I'm trying to say here is suppose what you are going to do. First, let us try to go from A to B. Sorry, A to directly D, right? First, we
Hmm.
are going from A to D directly.
Mm.
So the change in enthalpy, you can say delta H, right? If I am going from A to directly D, then the change in enthalpy of this is going to be delta H. If I am going from A to B, then B to C, then C to D, then what I'm going to say? For A to B, the change in enthalpy is going to be delta H1. For this 2, for the third one, delta H3. So what we are going to understand here is the value for change in enthalpy from A to D is equal to the sum of the A to B, B to C, and C to D. If I go back and again read the definition, what it is saying, the heat absorbed or evolved in a given chemical reaction is same, whether the process occurs in one step or several steps. Is it making sense?
Yeah.
So if we are talking about delta H A to D, then we can say it is going to be the sum of A to B, B to C, and C to D.
Sir,
These,
give me 1 minute. I'll be back.
the C,
Yes, you may continue.
now here, if I'm talking about delta H, which is A to D, it is going to be equal to it is going to be equal to delta H1, delta H2 plus delta H3. If I'm adding one more step, which let us take delta H4, then the delta H is going to be like this. We will count that as well, right? Let us try to see whether it is correct or not. Suppose I am going from A to B. The value I am getting is the change in enthalpy is delta H1. If I am going
Oh, yeah.
from B to C, it is delta H2. If I'm going from C to D, it is delta H3. So if I am doing this subtraction, like here what we have B and B common, we are cancelling it. C and C common, we are cancelling it as well. So what we are getting, the net reaction is A to D. Ultimately, I am going from A to D. For A to D, what I know, A to D is delta H, and the delta H is nothing but delta H1, delta H2, and delta H3. Is it clear?
Yeah.
This is your Hess law. Now, let us consider another reaction. We are going from A to product. Okay, this is second method to understand the same thing. Delta H is what? Delta H is basically your Q, which is heat, but at constant pressure. Can we say it like Q? Because it is heat again, but it is constant pressure heat. So we, to be more specific, we call it enthalpy. But it is still heat exchange, right? So what we can
So
say,
what's Q?
Q is your heat exchange.
883.
What is enthalpy? Heat exchange at constant pressure, right?
Yeah.
In your exam, they might give you it, they might represent the question in this way, like at delta H1 is Q1. So you should not get confused. They are talking about the same thing.
Okay.
Okay. So again, we will do this A to B, B to C, and C to product. Then ultimately the net reaction is giving you A to product, and A to product is your delta H. And delta H is nothing but sum of these three. And if I am saying my delta H is Q1, then I can say Q1 plus Q2 plus Q3 collectively as Q2. So according to Hess law, Q1 is going to be equal to Q2. Same thing.
Molecules?
What would
Wait. Q1 plus Q2 plus Q3
is
is
equal
equal
to
to Q2?
delta H? It is equal to delta H. Okay. But
Okay.
if I am talking about this specifically, I can consider it as Q2 because delta H, I am taking it as Q1. Just simplifying the thing. It is again the same thing. यहाँ पर what we can say, delta H is nothing but your delta H1, delta H2 plus delta H3. What I did, I took it as Q1, okay, Q1, and this Q1, Q2, and Q3. And collectively, what I call them Q2. So what I can say, Q1 is equal to Q2. That's it,
Okay.
right? Now, Let us take a question how or like how they are going to give you questions in your exam. Let's apply Hess law. Okay. This is a chemical reaction. You have given the equation 1 and its enthalpy value, equation 2 and its enthalpy value. You have to find the equation 3, equation three's enthalpy value. So you have to relate the first two and get a relation for the third one. So let us see how we are going to proceed with this question, right?
Yeah.
So what we are going to do is we have to use the equation 1 and equation 2, and we have to somehow convert it by by multiplying or dividing by a constant value so that we can get a equation which is resembling this, right? How we are going to do it? Let us see. If I am considering my equation 1 as x and equation 2 as y, what I can say?
Mhm.
How they are different. Suppose if I am where is my equation 2? This is my equation 2. Focus on this one.
Okay.
If I am dividing my equation 2 by half, what I'm going to get? This. Okay, let me do it.
How do you divide the equation by half?
See, let write the equation.
Hmm.
If I am dividing the whole equation by 2, 2, 2, and 2, what I'm going to get? 1, 1 by 2, and 1. This equation basically. Why I'm doing this, you will understand. Just give it few seconds, okay? What I did, I divided my equation 2 by 2. After dividing it by 2, what equation am I getting? This one. Is it going to affect it? No, because I am dividing it both sides. I am
Yeah.
dividing it both sides, and this equation still is balanced, right? Now,
Yep.
from x and y by 2, from this equation, from this x equation and the new equation that you have derived, the y by 2 equation, what you are going to do? You are going to use them. Basically, you are going to subtract them. Suppose uh, this is your equation x and this is your equation what? Y by 2. If you are dividing them, basically, so what you are observing, this will get cancelled out by this. And on the left hand side, you have s plus, if you are adding O2 plus half O2, you are getting 3 by 2 O2. And on the right hand side, you have SO3. If you go back and compare this equation with the third one, are you seeing any resemblance? This is the equation that we have derived. And is it not looking like the third one?
Yes. So,
So what we are going to do here is to find the enthalpy value for the third equation, the delta H3 value. What we are going to do is we are adding equation x and equation y and dividing it by 2. What we did? We took equation x. We have the value for equation x enthalpy, right?
yeah.
And we have equation two's enthalpy value. But to make it similar to the third one, what we did? We divided it by 2. So to get the value for enthalpy for the third equation, we are following this value, this trend. Like we are taking x, the enthalpy is given. We are taking y, the enthalpy is given. We are dividing it by 2, and hence we can calculate the enthalpy for the third equation. Is it clear?
Can you explain the x plus y by 2 again, real quick?
What we did? What we did? We saw the first two equation, right?
Mm-hmm.
And we have to do something or to convert it into the third one, right? Why we have to do it? Because as per Hess law, we know if we have the delta H value by subtracting or by subtracting or adding them, we can get the values for the third or first one, right? Like here. We know that if we are going from A to B, then if we have to calculate the final reactions value, we can just simply add the individual delta H values, right? So what we are going
Yeah.
to do here is, suppose if you have equation 1, and if you have equation, let us say the y1, if I am dividing my equation y by 2, I am getting this. And if I am adding this to
Mhm.
x, I am getting my third equation, or not? The first
Yeah.
step was to divide equation y by 2. After dividing it by 2, I get this equation. And if I add this to the x1, I get the third equation. So what I am basically doing, I am taking my y and dividing it by 2 and then adding it to x to get my third equation, delta H3. For y, what I have? For y, I have delta H2. The 2 one we have to take it because that's the entire thing. We were able to get the third equation. And x, delta H1. So what we know, that delta H3 is nothing but delta H2 divided by 2 plus delta H1.
Yeah.
Is it clear? This you just have to relate it. We will do some more
Yeah.
questions and it might click. Like, just see it, the entire thing.
Okay. Yeah, I understand.
Now, enthalpy changes during phase transformation. If you are going from solid to liquid, you will call it delta H fusion, right? What is delta H fusion?
Yeah.
It is the enthalpy change of the system when 1 mole of a solid substance is converted into the liquid state at its melting point, right? Delta H fusion for your water is 6 kilojoule per mole. And what is delta H vaporization? When you are going from liquid to gas, and for water it is plus 40.79 kilojoule per mole. And what is sublimation? Going from solid to gas, right? So
Yeah.
I think you might have known this before, like what is fusion, vaporization, and sublimation. Is this new for you, or have you heard about it?
Um. Yeah, I know that. I know this. We studied this in earlier classes.
Hmm. So basically, this is that thing only.
Yeah.
Vaporization means liquid to gas, fusions mean solid to liquid, and sublimation means solid to gas,
Yeah.
right?
Yeah.
Now, enthalpy or heat of formation. Enthalpy of formation or heat of formation. What is this? Let us talk about it. It is the enthalpy change of a system when 1 mole of a compound is formed from its constituent element. It is represented by delta HF or delta HF. So what it is? It is the enthalpy of formation. When you are making a compound and the heat that is evolving or absorbing by the system is called delta heat formation. So can you read this definition for me for on your own, just for like 1 minute? What it is
Okay.
saying? It is the enthalpy change. Okay, read
It
it for
is the enthalpy change of a system when 1 mole of compound is formed from its constituent
me.
elements. It is represented as delta FH or delta HF.
Yeah. So what it is saying, if you are making a compound from its constituent elements, the enthalpy change is called heat of formation. Right.
For
The
example,
second, for example, let us see. If you are supposed to make water, right? If you have
mhm,
to make water, can you make water this way? Have you seen a chemical reaction for the formation of water written like this? H plus O. What we take? We take H2 plus O2, right?
yeah,
Because like our constituent element for water molecule is H2, not hydrogen only, because hydrogen exists in the form of H2. If
yeah,
you are going for to find hydrogen, suppose let us take a simple example. if you are going to a shop, right? And if you are supposed to buy tomato, the shop owner will give you the whole tomato, right? When you take it to the home, you will cut it, but in the shop, you are going to get the whole tomato. Similarly, if our molecules or elements, we have to find hydrogen element, it is going to exist in H2 form. If you take it and did some experiment, you can break it into hydrogen alone. But when you are going to find it, you are always going to find hydrogen in the form of H2. Did it makes sense what I just said?
Yeah,
So this is not the right. This is not the delta H formation. Delta H formation, right? The actual delta H formation is going to be this because hydrogen exists in H2 and O2 oxygen exists in O2 only. They do not exist in simple hydrogen or simple oxygen. For this one, let us try to read the second definition. Second point, basically. It will explain what I just said. Read it.
yeah, just a minute. Okay. Second, all values of delta F H naught. What does not mean?
I told you in the last class, whenever we are introducing this not term, we are standardizing the condition.
Oh yeah, standard.
Standard
Okay,
condition. That means you have room temperature, 1 atmospheric pressure, like and unity concentration. Standardizing the
okay. Delta H naught for the elements in their standard states are zero.
Hmm.
Forming an element from itself, of course, does not yield a change in enthalpy.
Suppose, whenever you have an element in its standard state, the delta F H naught formation is always going to be zero. What I'm trying to say is, suppose if you are talking about the delta H formation of H2, delta H formation of carbon, whenever you are talking about the delta H formation of the elements which are in their standard state, the delta H formation for them is going to be zero because you have not formed them. The hydrogen gas exists on its own, right? When you look for hydrogen, you will find it in H2 form. So what it says, all values of delta formation H not for a standardization for the element in their standard states are zero. Forming an element from itself, of course, does not yield a change in enthalpy. Suppose you want to form hydrogen, right? You want to form H2 and you started with H2. So if you are going from H2 to H2, you are forming something. Are you forming something if you are going from H2 to H2? Is there formation of anything?
H22?
H2. Suppose you were looking for H2 and you took H2 and you just converted it like H2 to H2, reactant side H2 and product side H2. Are you forming something? No,
No.
because H2 exists in its free state, elemental state in dihydrogen state, right? So delta H formation of H2 is going to be zero. For carbon, if you are going to purchase carbon, in which state you are going to find it? Suppose carbon is potato and you are going to a shop and you are supposed to find carbon. So the shop owner will sell you carbon in simple carbon form, not C2, C3, only carbon form. The elemental state for carbon is simple carbon, right?
Yeah.
For example, if you are going to purchase nitrogen gas, in what form you are going to see the nitrogen gas? Is it going to be N? Is it going to be N2? Is it going to be N3? Is it going to be N4?
There again?
Nitrogen. Suppose I told you to go purchase nitrogen gas for me, right?
Okay.
So whether the shop owner is going to sell it in simple nitrogen state, N2 state, N3 state, or N4 state. In your atmosphere, in
Empty
your
state.
environment, N2 state. So it is its elemental state. So the formation, delta H formation is going to be zero for this.
Yeah, okay.
Is it making sense?
Yeah.
Okay. So this is not in standard state. So we are not going to use this equation for making H2O from your hydrogen and oxygen. You have to use this one. This is the fact, right? Some delta H formations are given. If you are supposed to make H2O in gas, the delta H formation is going to be minus 57.84. If you are doing the same thing but now in liquid, you have to you will observe more amount of heat release. If you are supposed to make HCl gas, right? So you will get this HBr this and NSC. Some general idea, some rough. You don't have to learn this. In your exam, they will give you the value.
Okay.
Now, if you have to make CH4, right? Now think again. If I have to make a sabji, right? I will get my potato, my other ingredients. I will mix it. So if I am going to get carbon, carbon will be in which form? Normal carbon form, right?
Yeah.
And hydrogen will be in normal H2 form. And I am supposed to make CH4. If I am reacting C plus H2, I am going to get CH4. Now, is this equation balanced? No. So I have to make it balanced and I
No.
have to multiply it by. So now this is a chemical equation, a balanced chemical equation in its proper state, in its elemental state. Similarly, what is this?
Uh, 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 Glucose.
So if you have to make glucose, you will take carbon, hydrogen, and oxygen in their elemental state. Carbon in C, H in H2, and oxygen in O2. Is it making sense? After this, you have to
Yeah.
balance. So let us see this question. Which of the following equation represents a reaction that provides the enthalpy of formation of CH3Cl? You have to make CH3Cl. How you can make it? The question is, so let us see. If I am going to purchase carbon, I will see it in carbon form, hydrogen in H2 form, and chlorine in which form? If you are supposed to find chlorine gas,
Cl.
in no Cl2, in it chlorine exists
Cl2.
in Cl2.
Cl. Oh, yeah, yeah, yeah. Okay,
It ex-
it's Cl2 only.
it exists in Cl2. You can break it into individual
Hmm.
chlorine atom, but you have to do some work on it. If you are going to
Yeah.
purchase it from your shopkeeper, he will give you in Cl2 form. You can make some tweaking in it. You can convert it into ClC, like whatever you want. It's up to you. But whenever you are going to purchase it, you will get it in Cl2 form. In our environment, it will exist and you will find it in Cl2 form. Right?
Yeah.
Now, I have to make this. So what I will do, I will balance it.
Yeah.
Uh, So how I'm going to balance it? Here I have 1 Cl and here I have 2. So I will divide it by 1 by 2. Okay. Here I have what? 3 H2, but here I have 2. So what I will do? I will multiply it by 3 by 2. Why? Because like this, I will get 3 hydrogen. Is it clear? So out of these three options, which
Yeah.
one is correct?
Third one. C.
Is it easy?
Yeah.
And and just by looking at it, you can see the hydrogen is given as high H form only. So it is again wrong. By
Yeah.
looking at the three element shape, you can tell. No, 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 no. This is a Jasola question. Give me a second. Now let us see this question. Again, what you have to find is from the following thermochemical equation, you have to calculate the delta H formation of cane sugar. You have given equation A, equation 2, and equation 3. And what you need to find is you need to find this equation with the help of the above. You have to do some tweaking in these reactions. You have to think about some combination which can give you this reaction. Is my question clear what we are supposed to do here? We
Which
have to,
reaction?
this one, we have to make cane sugar, right? The cane sugar chemical reaction is given like this. And to find this, we have some tools. We have these three reactions which we can tweak. We can multiply it by some number. We can subtract them with each other. We can add them with each other to get a chemical reaction which is looking like this one. Is it making sense what we are going to do? Like just the question part. We haven't started the answering. We are just trying to understand what the question is supposed. to get, like what it is trying to ask. Suppose
To
let us,
balance the sugarcane uh, chemical
okay,
reaction.
let us take a simple example. You have three colors, right? Red, blue, or green, and you have to mix these colors to get a specific color. So what you can do? You have to like mix them
Mix them.
basically. So we are going to mix these reactions in a way that we can create the third equation. So let us see what we can do. Is the question clear? Like you can ask me several
Yeah,
times
yeah,
because this is a little bit complicated because we have to think several combinations. We have to use like mathematical, like we have to use some maths here. Suppose we have equation one and I consider it as x. The first equation is x, the second one is y, and third one is z. So to
yeah. Okay.
convert to convert these equations into this one, what we can do is the first step is the first step is I can multiply my equation x by minus sign. If I am multiplying this equation by minus sign, what I will observe? My reaction will get reversed. This sign will go like this. Now, if I'm multiplying my equation 1, equation x by minus 1, then
Hmm.
the thing which one is reactant side, now it will convert into product side. The sign will get changed. Now this arrow is not like this, it is like this. Now this is reactant and this is product. Initially it was reactant and this was product.
Why did
Yeah.
you change it?
Because in my net chemical reaction which I'm supposed to find, the C12H22O11 is on the right side. To get it on the right side. Okay. After multiplying equation number x by minus 1, what I get? I just reverse this and I get this one. Right?
Yeah.
Is this equation
Hmm.
is like this? No, not yet. We have to do some more tweaking. Now what I will do? I will multiply my equation y by 12. Right? If I'm multiplying my equation y by 12, what I'm getting? 12C, 12O2 plus 12CO2. And the equation number z, I will multiply it by y, and then I will simply add them. After adding them, I will get my desired equation, which is this. And what
Yeah.
pattern I followed for this? For delta H, what I did? I multiplied equation z by 11, equation 12 or equation y by 12, and x by minus 7. You might be thinking in exam how I will be able to like think this much, right? Like
Mm-hmm.
why? So in your exam, they will repeat these questions. So if you are aware with this one, you will be able to do it. This is an NCERT question. Just see it, what we did. To get this net chemical reaction, this required reaction, what we did? We multiplied x, the first equation, by minus one sign, minus one sign. Why we did that? Because we need C12H22O11 on the right hand side. After that, the equation number y, we multiplied it by 12. Why we did this? Because we need to remove this 12O2 because in our net chemical reaction, we don't have 12O2. We need to eliminate it. And then why we multiplied equation C by 11? Because we need to eliminate 11H2O. Because 11H2O again is not in our required chemical reaction. Same goes for your CO2. 12CO2 is not in your net chemical reaction. By using this combination, we can calculate the exact delta H value. This is your answer. Is it making sense?
Yeah.
And please, like this is a bit thoda bahut complicated stuff because you have to think a lot about it. So I would request you just after this class, just note these two or three questions about Hessler. Otherwise, it will create some problem for you. Just do the Hessler part. Okay. Now this one, the answer is given. You have to explain in the next class why we are using this. This is again similar, like exactly the Hessler question. You have to tell me why we did this. Answer is given. I will ask you in the next class. Now the next topic is heat of reaction. What is heat of reaction? It is defined as the amount of heat absorbed or
Hmm.
released or the change in internal energy or the change in enthalpy during the complete course of reaction. What is heat of reaction? It is simply the amount of heat absorbed or released, or you can use the internal energy term or enthalpy term as well, because internal energy and enthalpy again are heat basically during a complete course of reaction.
Yeah.
So if we are talking about this general reaction AA plus BB, which is giving your product, then what we can see that the delta HR, the heat of reaction, is nothing but summation of your delta H formation of product minus delta H formation of your reactant. Delta H formation of your product, the summation, and delta H formation reactant with summation sign. So in the reactants, in the product side, what you are observing? You are observing C, small c, capital C. This C is what? Just the number of moles, and this C is what? Your actual compound. Oh, let me tell you. Suppose I am taking this equation. In this chemical reaction, what is product and what is reactant?
NH3 is the product.
And this two which I have like drawn here,
Reactants.
this is the number of moles, and this is your actual molecule, right?
Yeah.
This is your number of moles, which is a constant, and this is your actual molecule. So if I relate it here, this C is just the stoichiometry, the constant, the number of moles. And this C, this capital C is your actual molecule. For the molecule, you have to use the delta H formation because molecule is formed in a way, right?
Yeah.
And we will put this and we will subtract it with the reactant. And this is your heat of reaction. Is it making sense?
Yeah.
Pakka?
Yeah.
Enthalpy of free elements are taken as zero. I just told you na, like if you are talking about delta H not formation of H2 or N2
Mm-hmm.
or O2 or Br2 or C, like whatever element you can see in the environment is in free state. And if you are talking about its delta H not formation, and then it is going to be zero. What we can say, enthalpy of free elements are taken as zero. Is it clear?
Okay. Yeah.
Now, let us talk about this. In this question, what we have given, they are saying you have to calculate the delta H naught. Delta H naught is what? Your basically enthalpy change, but at standard condition. The chemical equation is given, right?
Yeah.
This is your chemical equation. And what you have to do is you have to just, for your heat of reaction, you have to just put this formula, your delta H product minus delta H reactant. In the product hand side, what you are observing? You have CO plus H2O. You will put delta H naught CO plus delta H naught H2O. On the reactant side, you have CO2, H2. Delta H naught formation CO2, delta H naught formation H2. Now, the delta H formation for CO2 is given, for CO is given, for H2O is given. And what we know, the delta H formation for H2, because H2 exists elemental state, like pre-elemental state for H2, hydrogen is H2. So for H2, we are going to take it as 0, and we just put the value simply, and we will get the delta H R. Is it clear?
Yeah.
Easy or not?
Yeah.
Now, factors affecting enthalpy of reaction. What factors can affect your enthalpy? The physical state of reactant and product. Why? Can you comment on this? Like how the physical state of your reactant and product can affect your enthalpy. What is enthalpy?
Change in heat when pressure is constant.
Good. So if I'm talking about that a physical state of your reactant and product can affect your enthalpy, then what it could mean? If it is a solid, and if it is a liquid, and if it is a gas, how the enthalpy can be related with this?
Oh.
Suppose you have a solid. To break a
Yeah.
solid, you have to provide some heat to it, right? If you are supposed to convert solid to gas, so you have to break the solid, you have to move the solid particles which are closer to each other to far away, right? So you have to put some energy
Yeah.
to it. If the intermolecular forces are strong, then you have to give more amount of heat. So state factor matters. Which state your reactant is in or product is in, right? The more
Yes.
the better the intermolecular forces, the more heat you have to provide. The more enthalpy you have to provide basically. And again the temperature and quantity of reactant. If you have less reactant, they will require less amount of heat and allotropic forms of reactant, right? If you have a carbon and diamond, which one is more strong?
Which one is?
Like which one you have to provide more enthalpy? Which one is more strong?
Okay, diamond, right?
Hmm. Is it clear?
Yeah. Can you end the class at 9:30?
That means 11.
Yeah.
Okay, just give me 3 minutes. Let us talk about this enthalpy of combustion as well. It is like छोटा सा, right? Just the definition part. We will do the numericals in the next class. Don't worry.
Okay.
What is combustion,
Combusting something.
right? So if we are talking about enthalpy of combustion, then what we can say, it is the enthalpy change when 1 mole of a compound combines with the requisite amount of oxygen to give product in their stable form. So if you have methane and you are reacting it with O2 and producing CO2, so this reaction is what basically your combustion.
Combustion.
You are reacting something with O2 and you are getting CO2, right?
Okay.
This is your enthalpy of combustion. And for methane, the enthalpy of combustion is this. Just for reference, again, you don't have to like rote memorize it. You will get this in your question. Suppose you have this molecule, C3H8, hydrocarbon basically. If you are